Hello friends, welcome to another video on LangChain series on my YouTube channel, and in this video we will cover chains in LangChain. So let's start. Here I have already done the setup. I have already created the venv environment and I have already set up my env variables. If you want to know how I did that, please watch my previous video on the setup. So I have already set up the open router API key in this .env file, and I am here loading and that env key. After that, as shown in previous video, I'm using Python and using chat OpenAI libraries. I'm initiating a LLM object. So here I'm providing a model which is GPT-4o mini. Temperature has been set to 1, and the API key as well as the API OpenAPI base URL. So as you know from my previous video, these two things are needed if you have Open Router API key. If you have OpenAI API key, then you don't need to provide these two variables. So all these three are optional as well. You just need to provide model if you have OpenAI API key. But for Open Router API key, since you want to use Open Router models, you have to provide the base URL as well as the Open Router API key explicitly. Otherwise, you don't need that. So you can just watch my previous video to know about all these things in details. We will just cover chains in this video. So we will cover totally 6 to 7 chains, and I will be dividing this topic into 2 separate videos to not to overwhelm you guys, because it's a little bit complicated topic and it's needed to understand all the further videos in LangChain. So let's start without any delay. So in here I have created two simple prompts. One is human message and one is system message. I have already covered these in the prompts video. You can just watch that if you need to understand what these do. So I'm just creating a prompt and I'm just invoking the LLM using this prompt. So this is a way to create a chat based prompt, right? And I'm just invoking the LLM based on that. So as you can see, this prompt says, tell me about galaxy in one line and act as an astrophysicist and provide answers on point. So as you can see, the LLM is giving me the answers on that. It's giving me a small description about that. So as I'm printing response.content, we are seeing this. Let's see how the response looks like. Let me remove the content from here and I'll just trigger this again. So this is what we are getting from the LLM. So as you can see, it also contains metadata and everything if you just remove the content part from it. And also LLM provides many more things, but LangChain is like doing things on top of that and providing you this as the answer. So let's see now. This is another prompt. I'm just creating using chat prompt template, similar prompt. Here I didn't use chat prompt template. I just use human message and system message. Here I will be using templates. So like I've already explained this one as well in the previous video. Just for the revision. Okay. So here I'm creating a system message prompt template and human message prompt template. A similar prompt like you act as some professor and answer this in a short sentence and tell me about the topics in these few points. So these I have kept variables. I have kept variables as persona, topics, and points, and I am creating a chat prompt template using these two system and question prompt templates. So here, if you remember from my previous video, you can just use the format to create the actual prompt out of this template and provide the variable values, or you can just provide the values during the runtime. So here I am providing the persona, topic, and the points during the runtime, and as you can see, when I invoke this prompt with the LLM, it will give me the answer accordingly. So here, if you will see the output of this prompt template, as I am printing this, so the system message and human message prompt template is giving me this, like they are just putting these values in the variables at the proper places, and the chat prompt template is giving me this prompt after putting the values in the proper places. So as you can see here, as I am providing Java and multi-threading, the prompt is act as a Java professor and so on, and tell me about the multi-threading topics in 3 points. Similarly, with the input values as gemologist, type of stones, and everything, the prompt will be something like this: act as a gemologist professor, obviously in the chat-based format, and you're just a minute. Gemologist answer in short sentence, and let's say tell me about the types of stones in 3 points. So next we will see how this works with chains. So let's start. So LLM provides you a class LLM chain. just to be sure, just to be clear, this is an old way of creating chains. I am showing this to you guys first because maybe you have seen something like this somewhere, but this is not the way we will be creating chains in the rest of the video. This is just for the knowledge that with the LangChain 0.1, this was the way to create chains. With the LangChain 0.3, they have introduced something called LCEL, which we will look further in the video, and we will be using that to create chains. This is just a small example, the way we used to create chains in the LangChain in 0.1. So in 0.1, we used to call this LLM chain class, where we used to provide the LLM and as well as the prompt template. So as you know, LLM and template I have created above, so I will be using this LLM everywhere further in the chains. I will not be creating LLM object again and again. I will be using the same object in all the examples. So here I'm providing LLM as well as the template. The template I have created here with the chat prompt template for this GML adjust and everything. And then I'm just invoking the chain. So invoking a chain is like similar to invoking an LLM. So as you see, I have seen in the previous example, calling the LLM was something similar, right? Like LLM.invoke and the messages. Whatever template you want to provide, you just invoke and provide the template. Here as well, when you invoke the chain, you just say chain.invoke, and whatever variables your prompt templates accept, you will just provide the dictionary of that. So my prompt template accepts a persona, topic, and points as a variable in the template. So I will be providing these three as a value in the dictionary. So you already know that once you provide these values, your template will look something like this after putting the values, right? So this will be getting passed to the LLM, and you will be getting the response something like this. So here I already have the response, but for you guys, let me trigger it again. Yeah, so as you can see, it's giving me 3 points on the types of stones, like precious stones. I don't know, I'm not going to read this all, but it's giving me the information about types of stones in 3 simple points. So now let's create similar chains using LCEL, which is somewhat latest in the LangChain. So LCEL is an expression language that helps you to chain 2 runnables together into a sequence. So runnables means the functions that can be sequenced in a chain. We will see how to create runnables on your own, or using LCEL. LangChain also provides you many runnables by default. So the output of the previous runnables.invoke call is the passes to as the input of the next variable. So let's read this all for now. I'll just explain you while doing the example actually. So this is done by using a pipe operator or using explicit.pipe method, which does the same thing. And types of LCEL chains are sequential chain, parallel chain, router chain, chain runnables, and custom chains. We will be covering all that. So in this video, we will just cover simple chain, sequential chain, and parallel chain. So I will explain these points in this example actually. So as you can see, if you compare with the previous example, I was calling a LLM chain class in which I was passing LLM as well as prompt as a parameter, right? But using this LCEL language, creating a chain has become much more simpler. So you already have your template and you already have a LLM created in the previous block, right? So here I have created the template and here I have already created the LLM, right? So instead of calling this whole thing and passing the param and everything, you can just use pipe operator, which is mentioned here, or you can just use a .pipe method provided by the LangChain. So mostly I will be using pipe operator to create all types of chains. So let's look into that. So now I'm creating chain just like this: template, pipe operator, LLM. That's all. So I'm not doing anything else. I'm not calling an object. I'm not creating an object. I'm not calling a class. No params and nothing. So this pipe operator is all you need now. You just pass the runnables, which is the template LLM, using the pipe operator, and what it does, it will pass the output of this particular thing as the input of the next. So as you know, your output of your template is this. We have seen the output here, right? When we invoke the template, the output of the template is this, right? So this will be passed to the LLM as the input. So as you know, your LLM accepts the template as input, right? So LLM.invoke, it accepts a template. So this is also a template, right? And if you go here, this template can be passed to LLM directly, right? Like you can just pass this template to LLM after getting the values, after formatting and replacing the variables with the values, right? Directly like this. So this is what will happen now here as well. only using this pipe operator. So when you are printing chain, as you can see, this is a runnable sequence. So remember, so these things are runnable, and this whole thing is a runnable sequence, like it's a sequence, right? First it will execute this, then the output will be passed as an input to this, and this will get executed, and the final output will be returned to you. So this is a simple chain, like pretty simple, right? Template, pipe operator, LLM. So to invoke a chain, like as you did here, chain.invoke, so this part remains exactly same. The way you were invoking this type of chain, you can use exactly same format to invoke this one as well. This is not changing, so nothing changes for you, only the way of creating the chains has become simpler with LCEL. So I'm doing the same, chain.invoke, persona, gemologist, topics, type of stones, and points 3, same thing, exact same prompt. And as you can see, the response I'm getting similar, should be similar. So see, same response I'm getting here as well. So now what is happening here, if you try to understand, here you provided the template, right? And when you did the chain.invoke, this input first went to template and then LLM. So in this class, probably things are written that way. I'm not sure about that, but here the same thing is happening. When you pass this as an input and during the chain.invoke, this input is passed to the template, which internally does something like this only. The way we are doing things here, template.invoke, and that input is passed here. This is getting called internally. This is returning you this prompt as output, and this prompt is getting passed to this LLM.invoke here. So instead of explicitly doing this whole thing, getting the output and passing it to the LLM invoke, you can just use chains to do this whole thing. Create a template, use pipe operator LLM, and first this will get invoked. The output of this will be passed as the input to this LLM.invoke, and finally you will get the response as the output. So the way LCEL or LangChain is making things simple to you, like you don't have to like invoke everything one by one and wait for it. You can just use pipe operator to create chains, and if you want your output of something to be passed as input to another function, you can just create your own runnables, or you can just create your own sequences, and you can just use them to chain them together. So this is a simple chain that I have shown to you. Now let's see. I will be covering a separate video on the parsers, but for this video, let's look into this string output parser. So as you know, if I remove this content here, right? If I remove this content and invoke it on again, so you can see you're getting this whole output, right? Not only the answer of LLM about these stones, you're getting the whole metadata, the whole dictionary, and everything, right? So to avoid that, either you are doing something like response.content, which which will just print you the content that is written by the LLM, or you can use parsers. So this is pretty simple, like you're just expecting a test, right? But there may be need to get the more complicated answers from the LLM, like a JSON, markdown, or many other different types of outputs, right? Then you can use different types of parsers provided by the LangChain to get the output in that particular format, like in a JSON or something like that. So string output parser will help you to convert the language model response object into a plain Python string by extracting only the text content, removing any unnecessary metadata or wrappers or everything. So the same thing that you are doing here, response.content, string output parsers does the exact same thing. So it will just give you the text response that is written by the LLM, and it removes all the other extra information from the response, like metadata or wrappers or anything that is present there. So we need it because LangChain Chains works with the structured masses objects internally, and the string output parser acts as a final step and that strips away the metadata and returns clean and usable task when no structured output is required. So because LangChain, the way LangChain classes and everything is written, they need this whole thing. They need metadata maybe for something else. They works on the objects, right? But sometimes you don't need all this extra information in your code, right? You just need the response, the text-based response that the LLM provides, right? So then you can use that parser to give you just the response. Obviously, all these are runnables, and you can just use them, include them in your chain as well. So same thing I'm doing here. From this output parser, the string output parser, I'm creating this parser. It's just pretty simple. You just have to call it like a class. And this is my prompt template. As you know, I've already imported the template on the above block, so I'm not doing it again. I'm using the things that I have already done here. So using this prompt template, I'm just creating a simple prompt. What is the capital of particular country? And this is my output parser. Now, chain 1 is prompt LLM. I'm not using parser here. I'm creating a second chain with the parser. So again, adding it to a chain is nothing, just adding a pipe operator and passing the parser to it. So now what will happen? First, your input, whatever input you pass while invoking the chain, it will first go to the prompt. It will just generate the output of this, which is like what is the capital of maybe country India. Then it will pass it to the LLM. LLM will get invoked. It will create an object, right? The object that we are seeing here, we saw here. That object will go to the parser, and parser will return the content or the text response to you. So let's see how the responses differ in those two scenarios. This is the chain without the parser, and this is the chain with the parser. Let me invoke it again. Already. So without parser, as you can see, you are getting this whole thing: metadata, content, and output token details, and everything, right? But with parser, you are getting what you need. This is the only response that you are getting with the parser. So as you know, instead of explicitly extracting out content from the object, you can just use parsers to get the response in a specific format. So there is other different types of parsers as well, not just a simple string output parser. I will be covering all of them in a separate video. So let's move forward with the chains only. So this simple chain is pretty simple. I hope you understand it. Let's move to a more complicated chain, which is parallel LCEL chain. So parallel LCEL chain is a pattern where multiple chains or runnables are executed at the same time on the same input using LCEL, and their outputs are collected together into a single result. Instead of running steps one after the another, LCEL allows you to branch the flow, so different prompts, tools, and models processes the input concurrently. So in short, basically parallel LCEL chain, they allow you to they allow you to invoke multiple sequences in parallel. So here what you were doing, first you were first you were invoking prompt, then it passing to LLM, and so on, right? Like it was sequential, right? It was like first invoke the prompt, then LLM, then parser, and so on, so on, so on. But with parallel LCEL chain, you can invoke multiple sequences in parallel. Like it will just trigger both the sequences together. It will collect the output, store that in a dictionary, and that dictionary will be passed as an input to the next sequence. So we'll see that as an example. First, let's see why we need it. Because of lower latency, right? For independent tasks, you obviously don't need to do it sequentially, right? You can do it parallelly. Then multiple perspectives, like getting summaries, critiques, extractions, like in one pass. So maybe you have a some doc and you want to extract different things out of it, like summary of it or critiques of it, or different things, right? Then you can just create different prompts, different chains, and you can just run all those chains parallelly. Like you don't need to wait for one chain to complete to trigger another, right? Because the only input all these three chains may need the doc or that paragraph, right? And they're not dependent on each other. Then clean composition, like combine results from different chains without a glue code. So it will just create, it will just return you the output of each chain like separately in a key value pair like a dictionary. We'll see that in the example. Then shared input and modular design, like fan out the same input to many tasks safely, and each branch stays simple and reusable. Also, cost efficient orchestration, like I watch repeated prompt setup and coordination logic and everything. You don't need anything. So here, this is one example. I'm creating three different chains. I'm again using the output parser, string output parser, and I'm creating three different prompts. Summary prompt, which says summarize the following text. Then key points prompts, like extract 3 key points from the following text, and questions prompt, generate 2 follow-up questions for the following text. So as you can see, all these templates, all these prompts are independent of each other. All of them are expecting a text, same text, and they are doing their own thing. They're not waiting. They don't need the output of any other template. They just perform everything independently, right? So for this, if you will see use this simple LCEL chain, what you will do, like you will maybe create a prompt, then pass it to LLM, then use another prompt and pass it to another, pass it to LLM again. Like you have to do it one by one, right? But as all three of them are independent and you don't need to wait for one to get completed, you can use parallel LCEL chain and use to invoke all three of them together. So first I will be creating simple chains out of these three prompts. So as you already know how to create simple chains, I am passing summary prompt, then pipe operator, then LLM and parser, and same for other two. Key points prompt, LLM, parser, and sequential prompt, LLM and parser. So this is like individual simple chains, right, that we have seen just now. Now to invoke them all together in parallel manner, you have to use something called runnable parallel provided by the LangChain. So what it does, whatever runnables you provide inside it, it will just take them, it will invoke them parallelly, and it will pass the input, whatever values you are providing while invoking the chain, it will pass this input to all of them. So if you remember correctly, while formatting the prompt, let me go up again. Yeah, you used to, in the template you used to provide a dictionary with the values, right? You used to provide a dictionary with the values, right? Same thing we are doing here. While invoking the chain, we are passing a dictionary with the text input value, and this input will be passed to, this dictionary will be passed to all three chains independently and parallelly. Summary point, key points prompt, and question prompts, they all will get the same thing again, same input. They will generate their prompts. They will pass their prompts, the LLMs provided in their chain. So you can pass different types of LLM as well, right? I'm using the same here. You can just create 3 different LLM objects with 3 different models and whatever you want, and you can pass it here, like, and they will pass it to their own LLM and own parser. You can use different parsers maybe in the different chains. So as you know, I am providing three key value pairs, right? Like summary is equal to summary chain, key point is equal to key point chain, questions is equal to questions chain. So what it will do, it will just trigger all these three chains together, and it will just generate the output of all these three chains, and it will provide you a dictionary with summary, key points, and questions. So as you can see in the output, I'm getting a dictionary. Just a minute. Yeah, so in the summary, I'm getting the summary of that particular text, right? Summarize the following text. My text is MCP servers allow LLM clients to use external tools securely. So it is just summarizing this whole sentence. Then in key points, I'm getting point-wise summary. So whatever I have extra 3 key points, right? I'm getting 3 points here. Then in the questions, I'm getting 2 questions. I've asked for 2 questions, right? So as you can see, I'm getting first and the second question. Obviously this whole thing is a text, so as you can see this /n is there, right? So this whole thing is a text, but because here you are using the string output parser, right? So each of them will be providing a string, whether it is points or whatever is there. It will just convert everything in the string and add it to the summary. You will be getting a dictionary. As you can see, it's a dictionary. And here you have 3 key value pairs with summary, and then key points, and then questions. And the value of these 3 is a simple string because of the parsers you have attached to all these 3 chains here. I hope this is clear. If not, like, you can just watch this example again, like go back to the video and watch this again. But it will be helpful if you understand this runnable parallel and the next thing, because these things will be used a lot, like in further videos. So this is how you create a parallel LCEL chain. Now let's go to sequential LCEL chain. Sequential LCEL chain is a pattern where multiple steps run one after the another, and the output of one step becomes the input to the next. That creates a clear ordered flow of reasoning or transformation, making it ideal when later steps depend directly on the earlier result. This is kind of similar like a simple chain. So let's jump into the example directly. Like, let's come back to this later. So it's like a simple chain only, but a bit complicated. How do we create it? So same thing, I'm doing it again. I'm creating a summary prompt, summarize the following text, and a summary chain, a simple summary chain. Then key points prompt and a key points chain, the way I was doing it above, and action prompt and the action chain. So the difference between this and this is, here the input that was needed to all three prompts was same, right? The text that we will be passing while invoking the chain. So they were independent of each other, right? But here, okay. Here you see if my first prompt accepts a text that will be initially provided, then my second prompt, which is key points prompt, it expects a summary. So this summary is the output of this particular chain. Whatever text is summarized by the LLM, it expects this as an input. Then my actions prompt, it expects a key point, which is the output of this key points chain. So this will provide you 3 key points, right? It accepts that as an input, and from that it will just take the it will just provide you the actions needs to be taken. So here the chains are dependent on each other. So these are simple chains, right? Now the output of a particular chain is needed in the next in the other chain, right? So this is called sequential chain, where the output of a chain is passed as an input to another chain. This is called sequential chain. Now, as you can know, I have already created these 3 simple chains: summary chain, key points chain, and actions chain. And to create a sequential chain, you have to do nothing, just pass them using pipe operator, same thing that we were using in the simple chain, and just pass the whole chains together. So here what I am doing, I'm just using this curly. I'm using these braces, simple braces, and I'm initially passing a object where I'm saying summary colon equal to summary chain. So why I am doing that? So let's understand what is happening here. So first I'm passing a dictionary, then I'm using a pipe operator. So whatever output this will give me, that will be passed as input to key points chain, which I have created here. Then whatever output this whole thing will give me, that will be passed as input to this actions chain, right? So now from the previous examples, you already know that summary chain will give me a string of summary, which we were getting here, right? A summary in the string format, this MCP server thing. So here this is coming in a dictionary form because I'm using runnable parallel, right? But if you will run this summary chain, it will just give you a simple string like this, right? Like this, the capital of India is New Delhi. It will just give you a simple string. Similarly, this chain, key points chain, will give you a simple string output because of this parser, string output parser. Same parser I have created here in this block, and it will just give you a string that will contain the points about it. Similarly, this will give you a string that will contains the action, whatever action you need to take. So, but as you know, the input of this key points chain should be a dictionary, right? Like if you will see here, I'm providing a dictionary, right? With the text is the input that is required by my prompt and value. So this will be needed in dictionary form, right? So what I'm doing initially, I'm creating a dictionary out of here. So I'm creating a summary and summary chain, and I'm just invoking this chain. So when I invoke this chain, this particular object, this is passed to this summary chain as it is. Now summary chain will get executed. This text will be replaced here as a value. This prompt will be created, and this will be passed to this LLM and then parser. It will return me an output in the string format, summary in the string format, that will be replaced here. So this whole dictionary will be created. Now it will be passed to key points chain, something like this. So after this is executed, something like this will happen. If I replace the sequential chain with key points chain, so after this block is executed, this thing is executed, something like this will happen. Key points chain dot invoke, and instead of text, summary will be there, and this will be the summary. This output, this whole thing, this will be passed as an input to this key point chain. After this block is executed, something like this will happen internally, and so on. So after this key points chain is executed, you will get the key points in string format, and that will be passed as a dictionary. So one thing you might be seeing here, and you might be getting in your mind a question in your mind, that here I am creating a dictionary, I am creating an object, but here I am not, right? Here the output of this whole thing is a string, and as I am not creating a object here, how it is getting converted into this object and getting passed to this exchange chain, right? So the thing is, since all our prompts, all these prompt templates, they accept only one variable, right? Single variable. So in LangChain, if your prompt accepts one variable, then whatever input you provide, either in this string, object form or a simple string, it will just take that and replace it in your that single variable. So if I remove this thing here as well, right? Like if I remove this whole object from here and run it. Okay, where is that? Okay, I got the problem. I'm invoking key point chain here, not the sequential chain. That is why it's failing. Let me replace that and let me try this again. Okay, where is that? Yeah, it worked, right? So as you know, I'm providing an object here, right? Here, if I remove that part as well, it still works, right? Because this thing get passed as an input in the summary chain. Summary chain gives you a string which gets passed into this key point chain. Since my variable is, I have only one variable, it's getting replaced here, and same with the key points in the action prompt. So whatever output this gives, it's a string. This will get replaced in the key points. So if I, let me try this. I have not tried this. Let me try with this thing. If I just passed a string here instead of the object, this is, how do I revert it? Okay, let me just pass a simple string instead of this whole object. Yeah, still works, right? Because now all of my prompts, this one, they accept a single variable. So even if you pass the object or a single string, it will just get replaced with that single variable. Let me revert it back. So even if you do not create this object in the sequential chain, it will work. But in case you have multiple variables, let me show you that as well. Let me revert this whole thing and make sure it's working. Yeah, it's working. Let me add more variables to it, maybe 3 key points, right? So let's create a variable n here with n key points. Now, as you know, this template, that takes 2 variables, but here we are saying I'm just providing summary, right? And let me trigger it again. So now, as you can see, the error came. So the chat prompt template is missing n variable. It needs n as well as a summary. So because here I am providing summary, not n, this is failing. So if I just do, let's say n colon hardcode to 4 maybe. Let me create a thing like that and run it again. It will just, it should work just fine. Maybe okay, I don't think you can provide it like this. I think you will need runnable lambda for that. We'll see runnable lambda later. So it's failing, right? Because it needs n as well in this thing. So similarly, if you'll remove this object altogether, it will still not work because your output is a simple string, right? And now it will not just get replaced in your key points prompt with the summary. So as you can see, missing mapping type input as chum prompt, expected mapping type as an input. So it expects a mapping. Now, as the variables are more than one, it expects a mapping instead of just a single string. So it's not going to replace the output of this summary chain, which is string, to any random variable. It just expects a mapping now, like what is the value of n and what is the value of summary. So since our prompt was having only a single variable, it was working without this mapping or with simple strings as well, right? So that is why it was working. So let me just do it again and run it again. So that's how it works. I hope it's clear. Let me just summarize this to you. So you have to provide the mapping. So if you have multiple variables, you have to provide the mapping to your chain. So since my first chain is a single variable, If I pass string or as well as the mapping, both will work. Both will get as an input in the summary chain, and I have to. I'm just creating a mapping here, but I don't need to, since my next prompt or next chain also expects a single variable. In case of multiple variables, you have to provide mappings, and you cannot just the string output that will be written by this will not be sufficient, because you have to provide the whole mapping, like what should be the value of that particular variable and so on. Only then it will work. With single variable, simple strings can be replaced by that. Simple strings are replaced by the variable with the variables by LangChain only. So let's see another example here. This is kind of a similar example where I'm summarizing the text and then again key points, and now I'm expecting a summary as well as key points in my next prompt. So here in this prompt, I was just expecting a single variable. Now the change is here my summary prompt and key points prompt remains same, but my action prompt expects summary as well as key points to provide you the action. Now I'm creating 3 different chains, like same chains: summary chain, key points chain, and action chain with simple chain. And I'm creating a full chain. In the full chain, I'm just using summary chain as it is. You notice, if you notice, like I'm not now creating this mapping, because my key point chain, it expects a single variable only. So I'm using a summary chain here directly. Then I'm using runnable lambda, which I was talking about earlier, which I should have used here. So what runnable lambda does, it takes the output. So it again creates a runnable for sure, and it will just take the output of the summary chain. It will pass this as an input to all wherever. It will just create. It's like a function, lambda function. So this output will be passed as a param to this lambda function, and you can just do whatever you want with this. So what I'm doing, this summary chain will give you a string, right? This string will come here as the input. Then you are creating a mapping here. So your action prompt, which is your last prompt, next chain, actually this chain, it requires 2 variables, summary and key points. So you cannot now use it like this only, like because this thing will create a simple string, and simple string will like LangChain will not know, right, to what variable that value is and what is the value of another variable. Then LangChain will not know. So you have to create a mapping now. So from this function, I'm returning a mapping which is summary, which is the exact summary which is written by the summary chain, and key points, which is the key point output of the key points chain. So in the key points chain, I'm invoking key points chain, and I'm passing the summary as a mapping here. Whatever is the output, it will be returned here. It is obviously it's a string because you are using parser, which is here, and it will be written here. And this whole object, this whole mapping will be passed as an input to the action chain, because it needs both of them as the input. So if I run this again, it will just return me a similar output. Let's see. Yeah, similar output. If you compare this with the thing, similar output, right? Kind of similar. But the way the inputs that chain needs, the way we are creating mappings is different. So runnable lambda is another function like runnable branch. If I summarize, runnable parallel, it helps you to create parallel chains. It will just invoke everything parallelly. Runnable lambda is a function provided by the LangChain, which helps you create runnables using a lambda function. So in the lambda function, you can do whatever you want. You just need to provide you just need to return an output that is according to your next chain or next runnable sequence. So I hope this is clear. Let's look into one more example about this. So here I have summary prompt, key points prompt, critique prompt, risk prompt, and action prompt. Too many prompts, right? So let's see. Summary prompt takes obviously a simple text. Then key points prompt takes a summary. It needs the output of the summary prompt. Critique prompt, it also needs the output of this key points summary prompt. Risk prompt, it needs the output of this key points, right? So this key points prompt. And action prompt, it needs the output of everything: summary, key points, critique, risks, and everything, right? So this is a bit more complicated scenario, like just for the practice I've created this. So let's see, let's create simple chains out of them. So summary prompt is summary prompt LLM parser, key points prompt LLM parser, same for everything, right? For all of them I have created simple chains right now. So summary prompt is fine, like you just need to provide the text. So I have created chains in 2 different ways here. let's look into the both. So let's first look into the first chain. Here I am providing summary chain, and while invoking the full chain, this full chain, I'm just passing the value of text here. So full chain will be this summary chain will be invoked by this text value, and this value will be passed into this summary chain. The output will be a string, as we have seen in the above examples. I am creating a runnable lambda now. Now my two chains are dependent on summary, right? This key points prompt and critique prompt, right? So what I am doing in my first full chain, where is that? Yeah, here. I'm creating a runnable lambda, obviously lambda function. This will summary output will be passed here as input, and I am creating a mapping here, summary and key points, and I'm invoking the key points chain. Next, I am using runnable parallel, where I'm using a combination of lambda functions as well as the critique chain and the risk chain. So my critique chain it requires a summary, and in my risk chain, I think risk chain, what the risk chain requires, it requires key points. So summary and key points, this whole mapping will be passed as an input to all these four functions. So this lambda function in X will get this whole thing. So I'm extracting out summary and passing it to summary. Similarly here, this X will contain this whole mapping. I'm extracted down key points and passing this to key points. Then in the critique and risk, this whole mapping will get passed. Now you may observe that critique and risk prompts, or the sequence, they need exactly one variable. So critique requires summary and risk prompt requires key points. But both of them will get this whole thing. Both summary and key points as a mapping will pass to both of them. So this is not a problem, because whatever these critique and risk chain require, they are present in this mapping, right? You have some extra information, you are passing just an extra information. That's not the problem. But whatever they require, that is present here. So this will work. So now this will create a dictionary. As you see how runnable parallel works, right? It will just provide me a dictionary with summary, key points, critique, and risk. This whole dictionary will pass to the action chain, and this is how action chain will get invoked. It requires summary, key points, critique, and risk, right? So this is how it's getting invoked. Now you may be wondering, this is just for a demo I have created, because my key points and critique prompt, they require summary output, right? So why not run them in the parallel, right? We can obviously do that. So next chain, I'm doing the same thing. I'm creating a summary chain, I'm invoking the summary chain, and now I'm doing runnable parallel first, in which I'm creating a summary mapping, then key points and critique mapping. So here what is happening, just a second. So this summary chain will get invoked. It will return a summary in string format. This will pass to this runnable parallel, and as we are using runnable parallel, this will automatically get passed as an input to all these three things. So this is a lambda function. Here I'm just returning whatever is getting passed. In the key point chain, this will get passed as a string, obviously not a mapping, because as you know, as you already seen, that if your chain or a sequence requires only one variable, you can just pass a string instead of a mapping. So this is how it's working again. And here if you will compare with the previous chain, I was using runnable lambda, right? So that's why I was doing the invoking part myself, like key points chain dot invoke, because runnable lambda just takes a lambda function, and it will execute whatever is written there. So you have to invoke the key points chain here, but here I'm using runnable parallel. So these key point chain and the critique chain will be invoked directly by this runnable parallel function only. I don't have to use this invoke function here. This I have to do it in the runnable lambda. So this string will be passed to all these three. The output will come, and I will get a dictionary of summary, key points, and critique from the runnable parallel. Then this dictionary will be passed to this runnable lambda data. Data will contain a mapping of summary, key points, and critique. I'm just extracting out whatever is coming in the data here, and whatever is coming in the data, I'm passing from that I'm passing the key points mapping to this risk chain. So again, I'm using runnable lambda here, right? So that's why I have to invoke my risk chain explicitly. The runnable parallel invokes everything on its own, but in runnable lambda, you have to invoke the chain on it yourself. It's like a function. It's like a lambda function. You have to do like whatever is needed and return the proper output for your next runnable sequence. The output of this, which will be like this, as well as the risk, will be passed to the action chain, and finally the output. So if I run this whole thing, you will see the output of these two chains are similar. The content might differ a little bit because LLM doesn't always give you the same answer for same prompt, but it will be similar actions. Let's wait for it to get completed. It's taking some time. Okay, I hope, because we have too many LLM calls, right? Uh, five, I think, five per each full chain, right? Yeah, we got the output. So you can see this is one output, one output of the one chain, and this is the output of the another chain. We are getting a similar output, I hope. Uh, yeah, a few things may be different, but texting will be different, but we are getting output from both the chains. So I hope this is clear to you. You can just watch this video again. If you are having doubts, you can just post your doubts in the comments. I will try to answer them, and I will be covering more chains in the separate videos, this router chain and much more, because I think this is enough for this video, and let's not get overwhelmed with all different types of chains. Maybe practice this on your own, like create different types of complicated examples on your own, like this, and try to play with runnable parallel and runnable lambda, and then you will understand difference and how to use and what to use where on your own. Like the best way to learn about this is like getting your hands dirty, exactly, honestly. Like, or in case of any doubts, you can either watch video again or post your doubts in the comments, and I'll try to answer them as soon as possible. Okay, that's it for this video. Have a nice day, and please like, share, and subscribe.